Okay, now I have come live on YouTube. So video I was actually recording a video for you where I explained about combined mathematics and streams available in the advanced level and why you have selected physical science stream and what are the subjects you want to study if you want to become an engineer. And in the later part of the video, I was trying to talk about the structure of the combined mathematics paper, and due to lack of storage in my mobile phone, the video suddenly stopped. And I have edited that video and uploaded, and you can first watch that video. And this is the continuity of that particular video, right? So I will provide the link of that particular video in the description also. So what I wanted to tell you is about the structure of combined mathematics paper, right? So I told you now in 2026 in any of the month you would write your final examination, right? So uh, in any month. Now first we have to look at the structure of combined mathematics paper, right? Now, when you look at the structure of combined mathematics paper, we have to look at the marking scheme also. So, we have to work for salary, right? So, here the salary is simply marks. Now, we will have combined mathematics 1. So, this is the structure of paper. Combined maths 1 and combined maths 2. Now, as I told you, the combined maths 1 is simply pure mathematics, right? So this is simply pure mathematics, pure maths, let's say. And this is applied maths, right? So applied maths. So without merely telling pure maths and applied maths, so before 2000, in which I was born, they had combined, the pure mathematics and applied mathematics separately. There were 4 subjects in A level. Then they combined zoology and botany together and named as biology, and they wanted to make the same amendment in maths also. So what they did is they couldn't find the common name for this, so they combined together and named as combined mathematics. That's all. They didn't just say maths, they just told combined mathematics, means they have combined pure mathematics and applied mathematics. Now we will look at the structure. So examination is time oriented. Examination is time oriented. Now you might have already written your O-level examination. So you should have written your O-level examination. But here the streams are not allocated based on the results, right? So soon after completing your O-level examination, before the results are released, you will be absorbed into GCE advanced level. So you already have the experience of writing an examination. Okay? Right. Now in mathematics, so in O level, you have 9 subjects. You had 9 subjects. So let's say you might have written English, science, and maths. So to make you easily understand, I will just tell you how you have written O level, the subjects in O level. Now in English, you might have spent around, I think, 2 hours, if I'm not wrong. Okay, I don't remember the time that you have to allocate for English, right? Okay, right, now let me tell about science, right? So in science, we had part A and part B, right? Part A and part B. In part A, you have 40 MCQ questions, right? Yeah, 40 MCQ questions. And in part B, you have structured essay, I think 4 questions, and you have essay questions, right? So for part A, you would spend 1 hour, and for part B, you would spend 2 hours, if I am not wrong. So altogether, you should spend 3 hours for writing the science examination. Means you have studied for 11 years, I think. So if you include kindergarten also, more than 11 years. Now you have to apply the knowledge that you have gained so far within these 3 hours and pass these science tests. Then only you can be qualified for GCE advanced level. Likewise, here I will tell about the time duration, because during the stipulated time you have to write the answer for this combined mathematics. Now for combined mathematics paper 1 and combined mathematics paper 2 we have 3 hours, right? So for combined mathematics the time allocated is 3 hours. Here also we have time allocated 3 hours. Okay, now in combined mathematics 1, so this is one paper, this is another paper, so they will happen separately. Combined mathematics will happen first, and then combined mathematics 2 will happen as the second examination, right? So first you will write combined mathematics 1 paper, then you will have a break, then you will write combined mathematics 2. Okay, right. Now in combined mathematics we have part A and part B. Part A and part B. Right? Part A and part B. And in combined mathematics 2 also you will have part A and part B. Part A and part B. Okay? Right. So in part A you will have in mathematics you didn't have, so you have studied science and mathematics in all level. You have written these 2 examinations also. In science you have multiple choice questions, but in mathematics you don't have any multiple choice questions. So I think you have 25 structured essay questions. Likewise, like you had 25 structured MCQ questions in all level, here you will have 10 structured essay questions. 10 structured essay question, and here also you will have 10 structured essay question. In applied mathematics also 10 structured essay question, right? Okay, then in part B, right, then in part B you will have 7 questions, right? So you already have, so in the paper this is how the paper will appear. So part A will be there, so you will have 1 2 3 up to 10 questions. Then in part B you will have 7 questions, which will begin from 11 12 13 14 15 16 17. So there will be 1 2 3 4 5 6 7 questions. Out of these 7 questions you have to write only 5 questions. You have to write the answer for only 5 questions, right? So only 5 questions. Now here for these 10 structured questions you will gain 25 marks, right? So each structured essay question will carry 25 marks. So for the part A you will gain totally 250 marks, right? And here for each essay question you will get 150 marks. So altogether you will get 750 marks. So for part A, for part A and part B of combined mathematics, you gain 1000 marks. So combined mathematics paper 1 carries 1000 marks. 1000 marks. Okay, right. And in part A, you will have 10 structured essay. So here also you have 250. Here also the same applies, right? So you will get 10 structured essay, and starting from 11 to 17 you will have essay questions, 7 essay questions. Out of those 7 essay questions you would write only 5 questions, right? Okay, now here also you have 1000 marks, right? Okay, now let me write here also you have 1000 marks. So what they will do is they will correct your paper, and altogether we have 2000, right? So for 2000, total 2000, how much you have gained? They will put this and they will calculate for 100%, and your final marks will be graded. So this is how they will, this is the structure of combined mathematics paper and marking scheme, right? So we have to prepare for these paper. So this is the ultimate target. Now, okay, now if your target is to obtain A, so we have to learn how much or how we can effectively and efficiently learn so that we can get more marks to get our desired ambition. So that is our target. Okay. Now let me erase all of these and bring you to the section, right? So here we are going to study. So in today's class itself, we will start the section in combined mathematics, right? So as I told you, we have a lot of branches in mathematics. So I named them earlier. Now we are going to study the basic concepts of algebra. So this is not, there will be no direct questions in your final examination, but to continue your journey in combined mathematics, you will definitely need these things, right? So here we are going to start basic concepts of algebra. Okay, algebra. So let's first say what is algebra. So algebra is a branch of mathematics, or we can say type of mathematics. It is a type of mathematics in which we use, okay, now in mathematics we do arithmetic processes like addition, subtraction, multiplication and division, right? So for example, mathematics mean what comes into picture? 2 plus 2 is equal to 4. 2 into 3 is equal to 6. So likewise, we deal with numbers. So this is number theory. Sometimes we might have studied, right? 2x is equal to 10. So x is equal to 5. So here this is basically algebra. Now, okay, here you see here, instead of 3, we have put x. Likewise. Okay, so to represent a number, we have used the letter. Sometimes we might study a lot of symbols also. So in a type of mathematics in which letters, we can say letters and symbols are used to represent quantities. Quantities mean numbers. Quantities. So quantity means this has a value. So this is a quantity. So to represent this quantity, for example, if you put 2 plus x is equal to 4, then we have to find out this x. So to represent a quantity, we have used letters, symbols. So that is basically algebra, quantities. So this is not necessary, because in mathematics they will not ask any definition like they ask in chemistry and other subjects, right? So first you should, learning mathematics. So mathematics, if I want to tell a truth about mathematics, now biology you will get an essay question, but you will not get any hint about the answer. But in mathematics only, they give the question and answer. So you have to take the question. So you will take the question. So you have the question, you have the starting point, you will get the ending point also. So you will just write how you can come to this position. So you have to write this answer step by step. So how you can obtain this answer. So in mathematics only you will get the question along with the answer. Okay. Right. Now we will start the first class today. Okay, this is not necessary. So I just told you algebra means we use letters and symbols to represent the right. Now algebra. So in algebra, first thing that we are going to study is index, right? So index. So these are very basic things. Now a raised to the power n, right? So we say this is called index and this is base, right? So base, and this is called exponent. Okay. So which means here you see a to the power n means a is multiplied n times. A times n times. For example, 2 to the power 3 means 2 is multiplied by multiplied 3 times. 2 to 2. So this is okay. But if you see an index like this doesn't means 2 times 3. This is wrong. So which means 2 power 3 means 2 is multiplied 3 times. So this will be equal to 2 times 2, 4 times 2 is 8. Okay, right. Now we are going to look at some definite results that we can tell regarding this index. Now a to the power 0 is equal to 1. So this is true for any numbers. A can be any numbers, right? So for example, 2 to the power 0 is equal to 1. 1000 power 0 is equal to 1. So 0th power of any number is 1. Okay? Right. The next result is, so this is the first result. So we can say some results. Some results. The second result is, now for example, let's say we have a power minus m. So normally we don't like negative. Being negative is not good in life. So we always try to be positive. So we have to make this value. So this value is negative. So we have negative. So in life we shouldn't see any negative. So if we want to make this as positive, so what we'll do is 1 divided by a to the power m, which means if we have a negative exponent in the denominator, sorry, if we have a negative exponent in the numerator, if we bring that number to the denominator, it will become positive. So a to the power minus m means okay, so here you see below we have 1. So if we bring this value to the denominator, it will become plus m. Okay. Now the vice versa is also true. By how? Here we say, let's say 1 divided by a to the power minus m. So what we will do is, we will bring this index to the numerator, right? So it will be a to the power m. Okay, right. Now I will do some examples regarding this. Okay. Right. So for example, let's say 2 to the power minus 3. So we cannot write like this because which means, as I told you earlier, here this means 2 is multiplied by 3 times. But here we cannot tell, right? 2 is multiplied by minus 3 times. So it violates the statement that we already taught. So we have to make this as positive. So what does it mean? So when you have a negative exponent on a base, we can bring it to the denominator if it is on the numerator. So it is like 1 divided by 2 to the power 3. So now we can again try 1. Here 2 to the power 3 means 8. We have already found out. 2 to the power 3 means 8. So the answer is 1 divided by 8. So for doing some calculations, we will need these ideas. So that's what we are teaching this basic concept in the very first class. Okay. Now these are the main rules that we have regarding indices, right? Okay. And again, I will take another example. So let's say you are doing a calculation, you end up with this one. Okay. 3 to the power minus 2. So it is not nice to see, right? So it doesn't appear to be convenient to the examiner to evaluate the value of this expression. So what we will do is, we will bring this denominator to the numerator. So when we do that, this will become 3 to the power 2. So the exponent will become positive. So 3 to the power 2 means that is 9. So this is the answer. So these things you should bear in mind. Okay. Right. Now we will see some theorems regarding this index. So you might have studied these theorems in your O-level also, but just to refresh your memory, I will just tell you. So there are around 4 theorems you might have studied, right? A power m multiplied by a power n is equal to a power n plus n. Now, if the bases are same and when the index is multiplied, we will add the exponent. Okay, we will add the exponent. So here the base is same, a power m and a power n, but the exponents are different. So what we'll do is, this will be equal to a power m plus n. We will just add the exponents. Right. Now let's do some examples here. Let's say 2 to the power 3 into 2 to the power 2. So this will be equal to what? This will be equal to what? 2 power, now we have to add these two exponents. 3 plus 2 is equal to 2 power 5. Now we will verify this, right? So whether this theorem is true, we will verify. Now to verify, we have to take the left hand side and right hand side. So here you see 2 power 3, we have this is equal to 8 into, here you see 2 power 2. So 2 power 2 means 2 into 2. 2 power 2 is equal to 2 into 2. So which will be equal to 4. So 8 into 4. So this is equal to 32. Now here you look at this one. 2 times 2 is multiplied 5 times. So 2 into 2 into 2 into 2 into 1, 2, 3, 4, 5. Okay. So 2 into 2, this is 4. This is also 4. This is 2. Now 4 times 4, 16. 16 times 2, that is also equal to 32. So verified. So this theorem is valid. Okay, verified. Then we will look at the second theorem that we have. Now, when two indices with same base are divided, we will just subtract the exponents, right? So this is like this. Second one, a power m divided by a power n. So this will be equal to a power m minus n. So let's look at an example. Now this will be, let's say, 3 power 2 divided by 3 power, okay, now let's say 3 power 3 divided by 3 power 2. So this will be equal to, according to our theorem, this will be 3 power 3 minus 2. We just subtract the exponents, right? 3 minus 2, which will be equal to 3. Now let's verify this theorem also. How can we verify this? Here you see 3 power 3. 3 times 3 times 3. Right? That is equal to 27, right? So 3 times 3, 9. 9 into 3, 27. Divided by 3 power 2 means 3 times 3. So that is 9. That is equal to what? 27 divided by 9 is equal to 3. So LHS is equal to RHS. So this is also verified. So this theorem is also true. Now the next theorem is a power m power n. Power of power. This will be equal to, now when we have power of power, what will we do? We will just multiply. So here you have to distinguish the differences between these theorems, right? So here the power of power will be multiplied. So this will be equal to a m times n. Okay, so now I have to tell you, right? So we will study a lot of theorems in combined mathematics, but the thing is, when you study theorems, you will not understand. But by doing questions or by doing examples only, you will come to know what exactly the theorem says, right? So here we will do some more examples. 2 power 3 power 2. So this is equal to, okay, 2 power 3 power 2. So this will be equal to, this is, instead of a we have 2, instead of m we have 3, instead of n we have 2. So this will be equal to 2 power. We just want to multiply these two exponents. So right. So here 3 times 2. So this is equal to 2 power 3 times 2, 6. So we will verify this. Okay. How can we verify this? So here you see, we will just take this, right? Now 2 power 3 is equal to 8. Now instead of 8, power 2. So 8 power 2 is equal to 64, right? So left hand side is equal to 64, and let's take the value of this. Now 2 is multiplied 6 times, right? So here 2 times 2, 2, 2, 2, 2. So 2 is multiplied 6 times. 1, 2, 3, 4, 5, 6. Now you see, this is 4, or otherwise we can say this is 8 and this is equal to 8. Now 8 times 8 is equal to 64. So LHS is equal to RHS. So this theorem is also verified. Now another theorem. Okay, right. So the fourth theorem is a power m power 1 over n. Now if we have a structure like this, if we have a expression like this will be equal to, we will just reinforce the knowledge that we have already studied. So power of power, but the power of power is a fraction. So what will be, it will be equal to a power m times 1 over n. So this will be equal to a power m divided by n. A power m divided by n. So this is just an example. Okay, so this is just, we have derived this. Okay, otherwise we can say this is a deduction. So this is a deduction from the previous theorem. We have just deduced another theorem. Okay, that's all. Another thing, the fifth is, okay, we can derive a lot of theorems, right? So I will just explain the fifth theorem also. The fifth theorem is 1 divided by a power m power n is equal to what? Okay, now you see, okay, you have already studied. Now a divided by b power n. So the power of a fraction. Now this power belongs to this numerator and this denominator. So we can write this as a power n divided by b power n, right? So this is the theorem. So this is another theorem, right? So we can name it as another theorem or another rule or another result, okay, whatever. Now you see, here I am going to apply this result here. Now this is equal to 1 power n divided by a m power n, right? Now I have already told you, right? So okay, now under result part I didn't tell this, right? Okay, now I told you under result part a power 0 is equal to 1, but 1 power anything is equal to 1, which means 1 power 1000, let's say 1 power 1000, this is equal to 1. Why? Because 1 is multiplied by 1000 times. Okay, I think you can't see this one, right? So 1 power 1000 is equal to 1. Why? Because 1 is multiplied 1000 times. So 1 times 1 times 1 times, so that is 1, right? So here this is equal to 1 divided by, now here we will apply this one. So this is equal to a m n. So this is the answer. So this is another deduction. Now we will study about some results regarding square root, okay? Now we will study some results regarding square roots. Square roots, okay? Right. Now square root means we say, right? For example, square root of 2. So you might have studied about square numbers, right? So there are perfect square numbers. What are they? 1, 4, 9, 16. So 1 means 2 times 2. Okay, I'm sorry. 1 means that is 1 is multiplied by itself. 1 times 1. 2 is multiplied by itself. Then 3 times 3. So these are called perfect square numbers. Now square root of this is equal to 1, right? Square root of this. Now if we have a number which is not a perfect square number, now we cannot define a value, right? So we cannot. So we will say that is surds, right? So you might just study about surds in grade 10 or 9, I don't remember. Okay. So now we will study some results regarding square root. For example, if you have 36, you will say this is equal to 6. Why? Because square root means this is power half. Power half. So which means 36 power half. So instead of this radical symbol, so we say this is radical symbol, we can put this value. Now here you see 36 can be written as 6 power 2. 6 times 6. Again we have half. So this is equal to what? We have already studied. A power m power 1 over n is equal to a power m divided by n. So this is equal to 6, 2 divided by 2. So that is equal to 6, 1. So that is 6. So this is how we derive this value. Okay. Now we will look at the results that I want to explain. So you know all these things, but These things are needed to continue our journey. That's why I'm explaining these things, right? So first result is, if we have like this, square root of b. So this can be written as square root of a times b. Okay, square root of a times b. For example, we have square root of, let's say I will take perfect 4 times square root of 9. So this can be written as square root of 4 times 9. So now let's check if this is correct. Okay, so verification is very important in mathematics. So this is equal to what? 2 times this is equal to what? 3. So 6. Now LHS is 6. Now this is equal to what? Yeah, now this is also equal to 6. Why? How can we write? Yeah, this is equal to square root of 36, right? So 9 times 4, 36. So square root of 36 can be written as square root of 36. I already explained you that is equal to 6. So LHS is equal to RHS. So this is one result. And another result is, if we have division symbol here, that will be equal to A divided by B. So let's take the same example. Okay, now let me take this so that you can easily understand. Right, so 36 divided by 4, right? Okay, now this will be equal to, according to our rule, we can write now 36 is divided by 4. So A divided by B. So we will divide the numbers within the radical symbol. So this is equal to 36 divided by 4. Okay, now let's verify this result. Okay, so here you see this is equal to 6 divided by 2. So square root of 4 is equal to 2. So this is equal to 3. Now here you see square root of 36 divided by 4 is equal to 9. So this is also equal to 3. So LHS is equal to RHS. So this is also verified. Okay. Now, but for addition and subtraction we cannot do like this. Which means A multiplied by B is equal to, we just divide the numbers that we have within the radical symbol. But if it is like this, square root of A plus square root of B, this is not equal to square root of A plus B. Okay, right, now I will explain it. Now let's take the same example I just took here. Okay, now you see, let's say 4 and 9, okay, 4 and 9. Okay, now this is equal to 2 plus 3, right? So this is equal to 5. This is equal to 5. But if you apply this one, let's say you say this is correct. Now if you apply this, what will be, okay, now how will it appear? So this is equal to square root of, instead of A we have 4 plus, instead of 9 we have 9. So this is equal to square root of 30. So square root of 30 is a surd, right? So this is not a perfect square number. But if we had gained the answer as 25, this would be correct. But this is not equal to this. And instead of minus, if we have minus, this is not equal to square root of A. Now, if we have two square numbers, two square root values. Now, if they are multiplied or divided, we can divide or multiply the numbers that we have in the radical symbol. But if the two surds, or we can say surds, right? So, if two surds are added or subtracted, we cannot apply that theory here. So, that is the idea that we have here. Right, now I think for today's video this is enough, and in the next video I will start the expansion of algebraic expressions, right? So in the next video what we will be discussing is the expansion of, you have already studied these things, right? So A plus B holding square is equal to A square plus 2AB plus B square. Now we will study, and we will try to expand these theories more. So for example, I don't know, you might have studied A plus B holding square, but what if it is A plus B holding cube, raised to the power cube? So what is the expansion of this? So these things we will discuss in the next video. Okay, till then I am going to stop this video and bye. And we will meet on another video. Thank you.